Hello, welcome to our video on an introduction to algebra and terms. Now I've started out here with an example written out for you, and we're going to use this example to talk about the different terms that you need to know. Now these are words that you will need to know the meaning of, so you want to make sure that you get these down in your summary book. The first term is an expression, which is a grouping of terms. We've got a grouping of different terms here. And an expression is when they're all grouped together, separated by plus or minus signs. So this whole thing in our example, this whole example is an expression. An equation is just like an expression, except it has an equal sign in it. So we could add to this one up here and put equals 6, or you could make it equal 6xy plus 3. It could be equal to anything. If there's an equal sign in it, then it's an equation. No equal sign, it's an expression. A pronumeral. Pronumeral is the letter part of a term. So if we look up here, and I'll just simplify this back to what we started with. If we look up here, the pronumerals that we have in this example are, there's an x, there's a y, this is another x, and this is another x. So in this example we have x's and y's are our pronumerals. Variable is just another name for pronumeral, so you can use those two words interchangeably. A term we've already talked about is part of an expression that is separated by a plus or a minus sign. So one term in this expression is 6xy. The second term is 2x squared. And the third term is 3x. Now if we had a negative on this 3x, we'd need to make sure we keep the negative there when we're talking about the term. It includes the whole term with the negative. In this example, there are 1, 2, 3 different terms. So you might be asked to calculate how many terms in an expression, and you just count them up in between the plus and the minus signs. Like terms are terms that have the same pronumeral part, and you need to make sure you include the powers as well. So if we look here, this term has an xy pronumeral, this term has an x squared, and this term just has an x by itself. These two are not like terms because this is just an x by itself and this is an xy together. So we would need to change this a little bit so we can find some terms, like terms. So I've added a few more terms into our expression now. If we're trying to find terms that have the same pronumeral part, let's see, we've got xy, x squared, x, y by itself, no. This is just a number by itself. Number by itself counts as a term as well. X squared y, haven't seen one of those yet. This one is xy and this one is x squared y, but it says here the powers have to be the same. So if this is x squared y, this one is just xy, they're not the same, they are not like terms. Here we have an x term and this was an x term here. So these two I'm going to underline in red because those two are like terms. And I'll put them down here as well. Negative 3x, remember to keep the sign with the coefficient. And 2x. And the last term we've got here is yx squared. And remember we can write this as, it doesn't matter what order the pronumerals come in. So that last term can be written as 3x squared y. And if we go back and look through here, this is an x squared term, but there's no y. But here is an x squared y term. So this term and this term are like terms as well. Make sure you keep the negative with the term. And 4x squared y. Coefficient is the number in front of the pronumeral. The coefficient of this term is 6. The coefficient of this term is -3. And I've put here, you need to include the sign. Don't just say 3 because that's incorrect. You need to make sure you say -3 for the coefficient of the x term. The coefficient of y, what colour will I do this in? Orange. The coefficient of the y term in this expression is -2. The coefficient of the xy term is 6. It's the number in front of the pronumeral. Four last words here that we need to make sure you remember are sum, which means adding things together. Difference means subtraction. Quotient means division. And product means multiplication. So these terms might come up if you're looking at a worded problem and you need to write it into an algebraic expression yourself. One that I need to add in here is constant. And a constant is a number term without a pronumeral. In our example up here, we've got one constant and it's in here. Make sure you keep the sign with it. If it was negative, it would be -12. But it's positive, so we can just write that the constant of this expression is 12. Some of the algebra rules that we need to make sure we follow. First one is write the number first, then the pronumeral. So we write 3x squared, not, written it around the wrong way again, x squared 3. So put a cross through that. We write our pronumerals in alphabetical order when we're fully simplifying. So on the last line, when you've done all your working, you need to make sure you write your numerals in alphabetical order. So you would write 3xyz, not, oh sorry, 2. I said 3, but I meant 2. 2yz x. Cross through that one. Start with the highest power in each term. This is a more advanced one, but if you're looking at getting absolute top marks, this is something you need to be looking at doing. 2x squared y would be how you'd write it, rather than 2yx squared. And that goes with what we said earlier, that the pronumerals need to go in alphabetical order as well. This one also applies when you're writing an expression. So if you have 2x squared plus 3x, you would write it like this, rather than 3x plus 2x squared. So we put the highest power first and then the next highest power. Just helps when you're organising, helps us to be able to read our algebraic equations a bit easier. do not write 1 as a coefficient. So if we have 1x, we don't write it like that. We just write x. You can put 1x in your workings, but on your final line you need to make sure you remember to take the 1 out and just leave the x by itself. Same with the power of 1. You might end up with an x to the power 1, but we don't write it like that. Just write x by itself again. X to the power 1 is what we're not going to write.